What if I told you that right now, at this very moment, there's an object hurtling through our solar system that defies every law we thought we knew about comets? An alien visitor so bizarre that scientists can't explain it, carrying pure nickel without iron. Something that only happens in human factories, while breathing out carbon dioxide like a living organism and growing a tail that points toward the sun instead of away from it. For the past 4 months, every major telescope on Earth has been locked onto this single point of light, and the more we learn, the less sense it makes. Time is running out. In weeks, it will vanish behind our sun, and we may never get answers to the questions that are keeping astronomers awake at night. Some are whispering the word no scientist wants to say out loud: artificial. But before we dive into the mystery that's unfolding right now in October 2025, we need to go back to where this impossible story began, because the truth is stranger than any alien invasion movie you've ever seen. May 7th, 2025. The Transiting Exoplanet Survey Satellite, scanning distant star systems for alien worlds, captured something in the corner of its field of view. A bright spot, moving. At the time, TESS was focused on its primary mission, hunting for planets orbiting other stars, so this local intruder went unnoticed in the flood of data. The automated systems logged it, tagged it, and moved on. Nobody realized that this tiny point of light was already beyond Saturn's orbit, already impossibly bright for something so far from the Sun. 2 months later, when the Atlas system in Hawaii registered the same object, now much closer, between Jupiter and Mars, the pieces started falling into place. Astronomers pulled up the TESS images. They ran the calculations. The object had traveled from beyond Saturn to inside Jupiter's orbit in just 2 months. The Voyager probes, traveling on direct trajectories to Jupiter, took 18 to 23 months to cover similar distances. This thing was moving at hyperbolic velocity, speeds that meant it couldn't be captured by the sun's gravity. It was just passing through. But here's where the first real alarm bells started ringing. When TESS first saw 3I Atlas out past Jupiter, it was already surrounded by a massive glowing cloud. Normal comets don't develop their characteristic fuzzy halos, their comas, until they cross Jupiter's orbit and approach the asteroid belt. That's when solar radiation finally becomes intense enough to sublimate the water ice, turning solid matter directly into gas without passing through a liquid phase. Yet 3I Atlas was already sublimating when it was still in the cold, dark reaches beyond Jupiter, where temperatures hover around minus 160 degrees Celsius. Something about this object was fundamentally different. Either it was made of materials that sublimate at far lower temperatures than water ice, or it was producing its bright halo through some other mechanism entirely. The early spectroscopic readings suggested carbon dioxide, lots of it, which does sublimate at lower temperatures than water. But the sheer brightness, the size of the coma, the rate of expansion? All of it suggested something unprecedented. As 3I Atlas accelerated toward the inner solar system through July and August, something even stranger began to happen. Comets have tails. Everyone knows this. What most people don't know is that those tails always point away from the sun, pushed back by solar wind and radiation pressure like a dog's ears flapping in a car window. It's one of the most reliable, predictable phenomena in astronomy. Except 3I Atlas's tail started growing toward the sun. Picture this: a cosmic wind blowing at 450 kilometers per second, carrying charged particles and electromagnetic radiation from the sun's surface outward into space. Every piece of matter in the solar system feels this pressure. Solar wind is what shapes comet tails, pushes spacecraft off course, and occasionally disrupts our satellites and power grids. It's a fundamental force, as reliable as gravity. and 3I Atlas was apparently ignoring it. The initial hypothesis was that maybe we were misinterpreting the imaging. Perhaps it was a trick of perspective, or perhaps we were seeing a secondary emission feature rather than the main tail. But as more observatories confirmed the same thing, the explanations became increasingly exotic. Some researchers suggested that maybe the object was venting material preferentially toward the Sun due to its rotation and composition. Others proposed that perhaps the tail was actually a forward jet of sublimating material from the sunward-facing surface, heated by radiation before the rest of the object. But none of these explanations fully accounted for what telescopes were seeing. A 2022 study in Nature Astronomy by Ye et al. Examined anomalous outgassing patterns in long-period comets and found that while asymmetric venting does occur, it still works within the framework of solar wind dynamics. 3I Atlas seemed to be operating outside those constraints entirely. Whatever mechanism was creating this forward-pointing structure, it was unlike anything in our existing models. When NASA's infrared telescopes finally got a clear spectroscopic reading of 3I Atlas's coma, the results were shocking. The cloud surrounding the object, now estimated at 300,000 kilometers in radius, nearly half the diameter of the Sun, was composed almost entirely of carbon dioxide. Not water ice with some CO2 mixed in, like the comets we know. This was CO2 dominant, at an 8:1 ratio with water. That meant there was 16 times more carbon dioxide than you'd expect in any normal comet. To put this in perspective, comets from our solar system's Oort cloud are typically 70–80% water ice by mass. Carbon dioxide, carbon monoxide, methane, and ammonia make up most of the remainder. The ratio matters because it tells us about the conditions where the comet formed, the temperature, pressure, and chemical composition of its parent star's protoplanetary disk. Our solar system's comets reflect the Sun's neighborhood 4.5 billion years ago. Their chemistry is our childhood photo album. 3I Atlas's chemistry tells a different story. The extreme CO2 dominance suggests it formed in a stellar system with radically different conditions, possibly around an older, cooler star where carbon dioxide could condense more readily than water. Astrochemical models by Mumma and Charnley, published in the Annual Review of Astronomy and Astrophysics, 2011, established that comet composition is essentially a frozen record of nebular chemistry. If those models hold, 3I Atlas is a messenger from an alien solar system with fundamentally different raw materials than our own. The object's core is now estimated at potentially 46 kilometers across, much larger than initial observations suggested. That's not enormous by comet standards. We've found solar system comets over 100 kilometers wide, but it's substantial. And it's outgassing at a prodigious rate, releasing enough CO2 to create that massive glowing halo. The sublimation rate calculations suggest the object might be losing millions of tons of material as it approaches perihelion, its closest point to the Sun. Scheduled for October 29th. Then came the observation that has no comfortable explanation. The Very Large Telescope in Chile, using high-resolution spectroscopy, detected nickel atoms in the coma of 3I Atlas. Nickel, a heavy metal forged in the hearts of dying stars and blasted into space by supernovae. This by itself wouldn't be unusual. Comets can contain trace metals. What made this finding extraordinary, bordering on inexplicable, is what the VLT didn't detect: iron. In the entire known universe, nickel and iron are inseparable partners. They form together in stellar nucleosynthesis, eject together in supernova explosions, and condense together in planetary systems. They're the two most abundant heavy metals in cosmic material. Meteorites, asteroids, planetary cores. Wherever you find nickel, you find iron. typically in specific ratios based on the conditions of formation. Nickel without iron is like finding oxygen without any hydrogen in a water cloud. It doesn't just violate expectations, it suggests something fundamentally weird is happening. There is precisely one known context where nickel appears without iron: industrial refinement by humans. We deliberately separate these metals for specific applications: nickel for corrosion resistance and alloys, iron for construction and steel. It requires heat, chemical processing, or electro-refining. It doesn't happen in nature. A 2020 study by Fitzsimmons et al. In Astrophysical Journal Letters analyzing the first interstellar comet, Tufau-Borisov found normal metal ratios consistent with solar system objects. The presence of nickel without iron in 3I Atlas has no natural formation mechanism in any current model of cometary or asteroidal chemistry. This is where the conversation splits. On one side, scientists working within the framework of known physics, trying to construct models that can explain 3I Atlas through natural processes, however exotic. On the other, a growing murmur of speculation that maybe, just maybe, we're not looking at a natural object at all. The alien spacecraft hypothesis isn't coming from fringe conspiracy theorists. It's coming from respected researchers asking uncomfortable questions in careful language. Harvard astrophysicist Avi Loeb, who famously argued that Oumuamua could have been an alien light sail, has pointed out that 3I Atlas exhibits several characteristics that are easier to explain through artificial means than natural ones. The nickel without iron finding, in particular, has no adequate natural explanation. The theories proliferate. Perhaps 3I Atlas brightened near Jupiter not because of sublimation, but because an automated system powered up as it entered a solar system, activating instruments or thrusters. Perhaps the massive CO2 cloud isn't outgassing from a dirty snowball, but deliberate venting from a life support system. Thousands of organisms breathing, consuming resources, exhaling waste into space, like a generation ship traversing the galaxy. Perhaps the object itself is alive, a spacefaring organism consuming interstellar dust and gas, metabolizing matter, and producing carbon dioxide as biological waste. Sound absurd? Consider that as of this moment, no one can prove these theories wrong. We don't have the resolution. We don't have the data. Every attempt to fit 3I Atlas into our existing models of cometary behavior requires special pleading, unusual compositions, exotic formation environments, lucky orientations. The alien hypotheses require just one assumption: that we're not alone. Everything else follows logically. NASA and the European Space Agency know they have one shot at this. In early October, 3I Atlas will pass within 28 million kilometers of Mars, still impossibly far by human standards, but close enough for the two European Mars orbiters to get a look. The Mars Express and ExoMars Trace Gas Orbiter will train their high-resolution cameras and spectrometers on the visitor, attempting to penetrate the CO2 halo and image whatever solid structure lies at the center. The resolution won't be enough for a close-up. We won't see surface features or structures, but it should be enough to determine shape, whether we're looking at an irregular chunk of ice and rock or something with geometry that nature doesn't produce. A sphere could be natural, an asteroid melted by internal heat into a round shape. But straight edges? Symmetry? That would be harder to explain. Then, on October 29th, 3I Atlas reaches perihelion, its closest approach to the Sun, passing within the orbit of Venus. From Earth's perspective, it will vanish behind our star's overwhelming glare. We'll lose sight of it completely until December, when it re-emerges on the outbound trajectory, already racing back toward the outer solar system. By then, it will be faint, distant, hard to study. The final opportunity comes March 16, 2026. 3I Atlas will pass within 53 million kilometers of Jupiter, distant but potentially within range of the Juno spacecraft, currently orbiting the gas giant. Juno is old. It's been operating since 2016, far beyond its original mission timeline. NASA had planned to deliberately crash it into Jupiter in September 2025 to dispose of it safely. But now, there's talk of an extended mission, a final assignment: intercept 3I Atlas on its way out of the solar system. Get close, get real data, answer the question. Here's what we can say with confidence. 3I Atlas is an interstellar object, confirmed by its hyperbolic trajectory and extreme velocity. It originated in another star system, possibly one that's twice as old as our Sun. From a region of the Milky Way with different chemical composition than our neighborhood. It's substantially larger than initially estimated, possibly 46 kilometers across. It's surrounded by a massive cloud of carbon dioxide that sublimated far earlier and far more intensely than any normal comet. Its tail exhibits anomalous directional behavior that doesn't fit standard solar wind models, and it contains nickel without iron in detectable quantities, a finding without precedent in natural cosmic objects. Here's what we don't know: what it actually is, whether the forward-pointing tail is a misinterpretation, an exotic outgassing pattern, or something else entirely. How nickel became separated from iron in its composition. Whether the massive CO2 production is geological, chemical, or could possibly be biological. What the solid object at the center of the cloud actually looks like. And most fundamentally, whether we're witnessing an exotic natural phenomenon or whether 3I Atlas represents something that didn't form through natural processes. The scientific method requires we exhaust natural explanations before invoking extraordinary ones. That's proper skepticism. But it also requires we follow the data wherever it leads, even if it leads somewhere uncomfortable. A 2023 study by Lingham and Loeb in International Journal of Astrobiology argued that the discovery of even one artificial interstellar object would have profound implications for our understanding of technological civilization in the galaxy. If advanced societies commonly send probes or vessels between stars, our solar system should occasionally receive visitors, though we'd rarely be able to distinguish them from natural objects without close inspection. 3I Atlas demands close inspection, and we're running out of time to provide it. In the end, 3I Atlas might be nothing more than a very weird comet, an object that formed under conditions we haven't encountered before, exhibiting behaviors that fall just outside our current models, but well within the vast parameter space of natural phenomena. The universe is large, old, and strange. It produces extremes we haven't imagined simply because we haven't looked hard enough. Or perhaps we're witnessing something genuinely unprecedented. Perhaps somewhere in the Milky Way. An ancient civilization sent objects like this into the void millions of years ago, automated probes designed to visit solar systems, gather data, move on. Perhaps 3I Atlas has been crossing the galaxy for longer than complex life has existed on Earth, following a trajectory calculated before our planet had continents or an oxygenated atmosphere. We'll have partial answers soon. The Mars flyby will give us shapes. The perihelion passage might reveal emission patterns that constrain composition models. If NASA extends Juno's mission for the Jupiter flyby in March 2026, we might get data that settles the question. Or we might get data that deepens the mystery. What we already know is this: the universe is weirder than we thought. Our solar system receives visitors from other stars. And those visitors don't always behave the way our textbooks say they should. Whether that weirdness is natural or artificial, whether 3I Atlas is a cosmic snowball with exotic chemistry, or something built by minds we've never met, it reminds us that we're still at the beginning of understanding what's out there. The telescopes are watching. The spacecraft are moving into position. And somewhere between Mars and the Sun, racing through space at speeds that will carry it back into the darkness between stars, 3i Atlas keeps its secrets. For now. If you want to follow what happens next, when the Mars images come back, when we finally see what's at the center of that carbon dioxide cloud, subscribe to the channel. This story isn't over. In fact, it might just be beginning. And if 3i Atlas teaches us anything, it's that the universe still knows how to surprise us.